Okay, hello everybody. Welcome to today's lesson. We're going to talk about section 12.5, the volume of pyramids and cones. In 12.4, a couple of days ago, we talked about the volume of prisms and cylinders. So today, the two shapes we'll cover are pyramids and cones. All right, first of all, there's a part of a pyramid or cone. Every pyramid and cone has what we call a vertex. Okay, so the vertex of a pyramid or the vertex of a cone is the point on the other side of the base. Okay, because every, like this cone right here, take a look at this. You've got the circular base. The point that the lateral surface converges to right here is the vertex of the cone. This cone down here, this is the vertex point. Here's a circular base. For a pyramid, same idea. On the back side, number one, which we'll do later, here is your base of the pyramid, and this point right here on the other side, all the sides converge to, is called the vertex of the pyramid. Okay? So every pyramid cone has what we call a vertex, if you hear that or see it, or if I refer to it. Now, pyramids and cones, there is a generic volume formula, just like there were for prisms and cylinders. It's right here. The volume of every pyramid or cone is, you still see base and height, capital B times H, but it's 1/3, capital B times H. Again, capital B is the area of the base. Occasionally you'll be given the area of the base. If not, you have to find the area of the base. So depending on the shape the base is, on the side you get the area of it, plug that in for capital B, and then H is the height. Now, look at this note I've made about the height, important stuff to keep in mind. It's not always straight up and down. Sometimes it is. Sometimes it is vertical, sometimes it could be horizontal or sideways diagonal. But the main thing about the height is that it's perpendicular to the base. Most of the time, the height is running through the inside of the shape. Okay, you do have a slant height for pyramids and cones, but remember, slant height is used for surface area. But for volume, you want the normal height, and most of the time, it's on the inside of the shape, like an imaginary dotted line usually, okay? The height can also be called the altitude, so that is a synonym for height. Because remember, altitude means it makes 90 degrees. And since the height is perpendicular, hits at 90, it is also referred to as the altitude. So if they give you the altitude, that is the height of the pyramid or cone. Now, one thing about the formula, 1/3. So it's capital B area of the base times the height, which is the same for a prism or cylinder, but pyramids and cones, you take 1/3 of that. Several different ways to take 1/3 of a number. You can divide by 3 at the end. You can multiply also by the decimal equivalent. Now, the decimal equivalent is 0.3 repeating. Normally, you can't plug that into a calculator, a repeating symbol. So if you're going to multiply by the decimal equivalent, I would keep several 3s to ensure accuracy in your answer. I would use at least 3 3s. So I would either divide by 3 to take 1/3 at the end, or really divide anything by 3, or I would multiply by 0.333, at least that many 3s for accuracy, to take 1/3. Okay, so pyramids, 1/3 capital B times H, also for cones. Real quick about cones. Right here, remember cones have a radius, also a slant height, which you do not use for the volume formula. Also, the normal height would be up and down through the cone, hitting at 90. Now, remember, you have a right triangle here. So if they don't give you the height, you might have to solve for it. So Pythagorean theorem possibly on some problems if you're not given enough. In fact, you might have to solve for the radius sometimes. Again, Pythagorean theorem is handy in case you need to solve for one of these because you do have a right triangle. And the last note before we do some problems on the back, remember last section we talked about oblique or leaning shapes. Oblique means it's kind of leaning. If you have an oblique or leaning shape, same thing in 12.4 that we talked about with prisms and cylinders, you're going to use the same volume formula. So don't change the formula. You do everything the same way pretty much. Use the same formula. Now remember I told you that the height is usually going on the inside. It's the height, like an imaginary dotted line on the inside of the shape. If it's oblique or leaning, a lot of times the height could be on the outside. Like if you have a cone that is leaning, say, maybe something like this, your height could be going up and down the outside, possibly. Okay, so the height usually is on the inside, up and down, not slant height for the formula. Or it could also be on the outside, possibly. All right, here we go. Let's hop to the back and look at number 1. We want to simplify the volume, so let's bring up our volume formula. The volume is going to be 1/3, capital B times H. All right, we see our height right here, 21. Now, capital B is area of the base. So for capital B, we need to find the area of the base. We see it's a square base, sides of 18. So the area of the square base is going to be 18 times 18. And when we multiply that out, we're going to get 324. So now we can plug that in for capital B. Now look, you have a nice number 21 that if you take 1/3 of it, it's a whole number 7. So if you want to, you can take 1/3 now instead of at the end if you want. It's up to you. So 324 times 7 will give us our answer, which comes out to be 2,268. And remember, volume is cubic units, so it looks like inches cubed. All right, let's look at number 2. All right, number 2, we have a cone. Now 16 is your slant height L. You're not going to use that for your normal height. We do have our radius 6.4, and we're going to have to get that slant height. We're going to have to get that regular H height going up and down the inside. That's what we need for volume, for the volume formula. Well, we're going to do Pythagorean theorem to solve for it. We're probably going to get a decimal. So these are your legs. So h squared plus 6.4 squared equals L squared, which is 16 squared. I'm going to skip a few steps here. Pythagorean theorem. When you solve this equation for your height, you're going to get about 14.7. Okay, so our volume formula, 1/3 B times H. Capital B is the area of the circular base. So we're going to have to use pi r squared on the side over here. 6.4 squared. Now we've already got a lot of decimals already in play, so we might as well just turn pi into a decimal and get an approximation. 6.4 squared is very close to 41. And multiply that by 3.14 for pi gives us about 128.7. All right, so now we can plug everything in. So the volume is going to be, I'm going to divide by 3 at the end for 1/3. 128.7 for B. times HR height, which was 14.7 when we used Pythagorean theorem to solve for it. All right, so we multiply 128.7 times 14.7. And that gives us about 274.9. We divide that by 3. Hold on, I typed this up wrong. All right, so 128.7 times 14.7 rather gives us a much larger number, 1891.9 about. We divide that by 3, and we come out with about 630.6 for our volume. And that is in, looks like centimeters, so cubic centimeters or centimeters cubed for the volume of the cone. All right, let's look at number 3. Okay, number 3 says we have a triangular pyramid. It gives us the volume, 708. It gives us the base area, 240. We got to find its height. Well, let's bring up the volume formula. All right, we plug in 708 for V, the volume. Third is a third. Capital B, it gives us 240. And H is H, that's what we're solving for. All right, so you'll see we have to work backwards here to solve for H to get the height. You can take a third of 240, that is 80. So 708 equals 80H. And we divide both sides by 80. So divide by 80 to isolate H. And 708 divided by 80 gives us exactly 8.85. And it looks like our unit was inches. So our height is about, or rather exactly here really, about 8.9 or equal to 8.85 for the height. All right, let's look at number 4. Number 4, we have a square pyramid. Gives us the height, the volume. We have to find the side length of the base. All right, so again, let's bring up the formula. Plug in what we know, see what we have to solve for. All right, it gives us the volume, 530. Plug that in for V. A third is a third. Capital B, we don't know, but we do know the height, 15. 15, sorry guys. All right, again, if you want, you can take a third of 15 because it's a nice whole number. It's 5. So now our equation is 530 equals 5B. And we simply divide by 5 on each side. And capital B is 106. Now remember, this isn't your answer. Capital B stands for the area of the base. The question wants us to find the length of each side. And it is what type of pyramid? A square pyramid. That means the base is a square. So look what we have. We have a square base, all sides the same, the area of which is 106. So we have to find the length of the side. All right, if you know the area of the square, you know side times side gives you that. So all you have to do is take the square root of the 106, and that will give you what each side of the square is. So the square root of 106 is about 10.3. And that would be what each side of the square is. And our unit is feet, so it's about 10.3 feet. All right? Guys, a couple of hints on the bottom. Let's take a look. I did change on your note sheet. I did not assign homework number 20. So you're not going to need this. But I am giving you a hint on number 22. On homework number 22, you first have to solve for h. Get your h value, your height, by using the Pythagorean theorem. Then you should be able to plug everything into the formula and solve for what you have to solve for, okay? Also, a homework hint on number 16. Follow this. Again, first use Pythagorean theorem to find the other leg of the triangular base, okay? And then after you do that, you can find out what the area is for capital B. And then you can plug everything in and work backwards to get the height h, okay? So there you go. Those 4 examples, 2 homework hints. You should be okay on the majority of everything else. And that is it for 12.5, guys. Volumes of pyramids and cones. I will talk to you next time. Have a good rest of your week.